Hello everyone, welcome back to this lecture. In this lecture, I will discuss what are the types of machine learning. In previous lecture, I discussed about what is machine learning and what is the motivation behind learning the machine learning through examples. In this lecture, I will focus on the supervised machine learning. So let us start the this lecture. First, machine learning is a branch of AI that enables the computer to learn from data without being explicitly programmed. Instead of writing the code with a specific rule, we provide data and let the machine figure out the underlying pattern in the data. So there are three major types of machine learning. First is supervised machine learning. Let me take a pen. First is supervised machine learning. Second is unsupervised machine learning. Third is reinforcement machine learning. In this lecture, I will discuss only supervised machine learning. Rest of two types I will discuss in upcoming lecture. So, supervised machine learning is a type of learning that where model learn the pattern which is hidden in the labeled dataset. Yeah, this is a labeled, that is a very key point. We need to provide attention to it. Labeled means we have a input and output pair. Think like a when we prepare for a exam, we have a questions as well as answers. Then in exam, we get a question and we try to answer that question. So this pair, we feed this into the model, and machine learning algorithm, they figure out the underlying pattern and recognize the pattern and learn it. And after this, we use this model for our task. So here is a labeled, means we have a input output pairs. We have a data in the format of x and y. X is a features, y is a target variable. Target variable may be a continuous and maybe a categorical. Continuous means it may be infinite value, it may be any value. A categorical means we have a finite values. We can like we are choosing a color among the list of colors. We have a very few option to select it, but in continuous we have infinite values. So based on the nature of the output we get from that model, we further divide the supervised machine learning into two types. First is regression, second is classification. In regression, output is a continuous values, and in classification we have a target is a categorical, that is finite categorical. Suppose you want to classify, you have a lot of data set in the format of image, having cat image and dog image. You are trying to feed this image into a model, and model try to predict it is dog or cat. So we have two only. We get only cat or dog. There is no other option there. But in case of regression, we can have any value. Like we are trying to predict the temperature, house price. So that is a continuous value. That is the main difference between the regression as well as classification. This two type of task is solved under the supervised machine learning. So I will discuss the regression and classification in depth. Move backward. So output is a, I discussed earlier, output target. Target is a key term. Target variable is a continuous value. We have a x and y. This data we feed in the model. Then model learn the underlying pattern hidden in the data set and train model used for regression task. So take example of house price prediction. In this we have a number of features. I choose three features: number of bedroom, location, and square footage area. These features I can write like x1, x2, and x3. Okay. Column is a feature, and I will write here target. That is the price of house. Or here row is a number of data set we have. I can write here sample, example. Oh, this column is a features. These features. Okay. I remove. Okay. So this is a feature. So this is a target. Yeah, we can say label. Not label. When we are dealing with the regression task, we use the target. Label is reserved for classification task. So I remove it. So we have a feature as well as number of samples. This data set. This is X or this is Y. I take a different pen. Yeah, this is a X. This is Y. So this data set fit into a model. Model learn the underlying pattern in the data set, and this model can be used for to find out the predict the price of house. Price of house. Price of house value is a continuous. That is infinite value. Price of house. Okay. Similarly, if you are building a project where you given a task of predict the stock price, stock market prediction, so you have a number of features. I will use this terms, key terms, that is the machine learning terms, that is the features. We feed data and we have a as well as target stock price, na, target variable. Okay, we give to the data set and model learn that pattern, and we can use this for stock price prediction. And similarly, for if you are try to forecast the temperature, that is used widely, we will give a number of features that define the how what should be the temperature in future. So we give a past temperature, humidity, and wind speed, and many other feature can be. And we feed also target variable. Target variable. This supervised learning. So we give a data in the format of x and y. Okay. Then we can use this model for temperature forecasting. And if you are given a task of finding the salary of a employee, so you need to consider the number of factor. This factor we called in machine learning is a features. This is a features. Features we use to train a model to detect to predict the salary of a employee. So feature your experience, what is the level of educations, and what a job role and company revenue. And we also give a value target value that is in the format of continuous value, and we feed this feature and target value, and we get a trained model. We can use this model to predict the salary of a employee. And second type is a classification. Here target variable is a categorical or label. To explain this classification task, I take example of email spam detection, in which we have a data set having a text, and text like this text 1 2, and having a label that is spam, non spam. We feed this data set in the format of x and y, or this data set feed into the model, and the model is trained and learn the pattern which is present in the data set, and that can be used for to distinguish between the text is spam or non-spam, or that is used in daily life. And next example is disease diagnosis. Suppose you have a X-ray image. You are trying to find out the hidden pattern, to find out the this image which is of a person. It person is healthy or not. So we can use uh, this machine learning model, which can understand the what is the features of an image, and we give a target target variable like this is healthy, not healthy, and our model can help us to predict the is it is healthy or non-healthy. And next example is sentiment analysis, in which we have a text and as well as label. We feed this data into model, and we are trying to predict it is positive sentiment, negative, and neutral. This is called a multi-class classification. Earlier example show the binary classification, or this example show a multi-class classification having a more than two classes. So we feed a text which represents some sentiments, and having a label which is maybe a positive, neutral, and negative. We feed the data set into the model. Model try to learn the pattern which is present in the data set, and predict the positive and neutral and negative sentiment. Next example is a binary classification example, which is we have a number of images of dog images. This is cat images as well as dog images, and these images and which these images are labeled with the cat. This is labeled with the dog. Data are feed into the format of x and y, and feed into the model. Model try to learn the pattern which is present in the images, and try to relate with the label as well as features we have in image present. And after learning, we can use this model for prediction task. We give a new image of a like cat or dog, try to predict the model is working well or not. So I hope this lecture provide a varied insightful knowledge. And still, if you have any question, leave that question in a comment section. Thank you so much. See you in next lecture.